Welcome back to AI.Code.Cast. You know we love to dive into cool coding challenges, and what today we've got one that's, I think, deceptively simple, at least when you first hear it. But we're going to find out that it's got some real depth to it when we get into the solutions. We're going to tackle the grumpy bookstore owner problem.
Mm. Does sound kind of amusing. But, like a lot of these coding challenges, it actually does connect to some real world optimization problems that you find in all sorts of fields. So even if you're, never going to run into a grumpy bookstore owner, these techniques we're going to look at, well, they apply pretty broadly.
Exactly. So picture this, right? You got this bookstore owner, and well, let's just say they have their moods, right? Some minutes they're grumpy, and when they are, it kind of affects customer satisfaction. But here's the thing. They've got this, I don't know, secret technique to become not grumpy for like a specific amount of time. And so the challenge is to find the absolute best time to use this technique so you can make the most customers happy.
Yeah, and we're given data on when customers arrive each minute and whether the owner's grumpy or not at that time. So it's like you've got this timeline of the whole day, and we're trying to place this not grumpy period on it to strategically create the happiest customers possible.
It's kind of like a puzzle, right? Where we got to fit this happy window into just the right spot. So where would we even start with something like this?
Okay, well, a straightforward way, and often a good place to begin, is brute force. We could literally just check every single possible time window for where that not grumpy period could go. Then we just calculate, okay, what's the customer satisfaction for each one? It's kind of like, when you've got that giant key ring and you just try every single key until you find the one that unlocks the door. You'll get there in the end, but it might take a while.
Right. Makes sense, especially if it's like a short day and a small key ring.
Hmm.
But I can imagine if the bookstore's open for like hours and hours and we've got tons of possible happy window placements to try. I mean, wouldn't brute force just be super inefficient if we're dealing with lots of data?
Oh, you're absolutely right. Brute force gets really expensive. Computationally, the bigger the problem gets. It doesn't scale well. That's why we're going to come up with smarter algorithms, something more elegant, I guess you could say.
So how do we move beyond just trying everything? Is there a way to avoid like redoing that whole calculation every time we shift that window? What if we could just update the satisfaction count, based on how the happy window moves? Almost like a moving snapshot of how happy the customers are.
That's actually a really great insight. You're getting at what's called the sliding window technique. It's way more efficient for this type of problem.
Sliding window. Okay, I like how that sounds already. So tell me, how does that work?
Okay, so instead of recalculating everything over and over for each possible window, we imagine this window, right? And it's a fixed size. It's the length of that not grumpy time, and it's sliding across our timeline. Now, the key here is as that window slides, we only need to update the satisfaction count based on what changes at the edges of that window, who's coming in, who's going out.
Gotcha. So as the window moves, we just adjust the count. We're kind of focused on the changes, not the whole picture each time. That sounds way faster than starting from scratch every single time. Can you give me like a specific example of how that window update would actually work?
Absolutely. Let's say that not grumpy period is 3 minutes long. Okay, so our window starts at the very beginning of the day, covering the first 3 minutes. And we just figure out how many grumpy customers were there in that initial window. Now we slide the window 1 minute to the right. We only have to subtract the customer count from that first minute. It's not in the window anymore. And then we add in the count from the fourth minute because that just entered the window.
I see. We're adjusting for the minute that went out and the minute that came in. So we're keeping our calculation nice and focused. But what if the best place to put that happy window is like split? What if it goes from the end of the day and wraps around to the beginning?
Right.
Would the sliding window catch that?
Ooh, very good question. It brings up something really important. We got to think about those wraparound cases. So imagine that the timeline is actually a circle, not just a straight line. So if our best window goes across the end and then back to the beginning of the day, we've got to make sure our sliding window can handle that.
Okay, so we got to make our algorithm treat the timeline as continuous, even if it loops around. I can see how that would be tricky. So how do we deal with those wraparound cases then?
Well, one way to do it is think about extending the timeline conceptually. Imagine taking a copy of the original timeline and just sticking it onto the end, right? That way, when the sliding window gets to the end, it just smoothly transitions onto that copy and loops back to the beginning. It's like we're giving it permission to go on a little adventure that circles back around.
Like the window gets to go on a little joyride. But okay, this is really cool. But I got to ask, does this sliding window thing, does it always guarantee that we're going to find the absolute best placement for that not grumpy, period? Or are there times when it might miss the optimal solution?
That's a really sharp question. For this problem specifically, where the not grumpy time is always the same length, yeah, the sliding window will definitely find that best solution because, it looks at every single spot where that fixed size window could go. But let's say we had a more complex scenario, right? Like, what if the not grumpy times could be different lengths? Or maybe they could happen multiple times throughout the day. Then we might need to think about a different approach altogether.
Makes sense. It's like the sliding window is perfect for this particular job, but for other variations, we might need different tools from the toolbox. So even within the sliding window world, are there different ways we can implement it?
Oh, definitely. One pretty common way is to track two separate sums as the window slides along. One for the grumpy customers in the window and another for the not grumpy ones.
Why would we split the sum like that? Doesn't that just make things more complicated?
Actually, it makes the updating logic a lot simpler when the window moves. So when the window slides one spot over, we subtract that leftmost value from the right sum, grumpy or not grumpy. Then we add the new rightmost value to the correct sum. It really streamlines things.
Okay, so instead of checking the mood for every single customer each time the window slides, we kind of pre-calculate those sums for each window spot ahead of time. It's like doing some prep work up front to make the sliding process super smooth. I bet this is especially helpful when you've got a really long day with tons of customer data.
Exactly. These little optimizations might seem small, but they make a huge difference when you've got massive amounts of data to work with.
It's all about efficiency, right?
Yeah.
Every little bit helps. So are there any other ways we can approach this grumpy bookstore owner problem? Or is the sliding window like the ultimate solution?
There's another neat technique we can use. It's based on this idea of a prefix sum array, and this one offers a different kind of trade-off between how fast it is versus how much memory it uses.
Prefix sum. Okay, that's a new one for me. What is that?
So imagine you have an array, right? And each entry in that array is the total number of grumpy customers up to that point in time. So it's like a running total of all the grumpiness so far.
Okay, so it's like a snapshot of how much grumpiness is built up at each point in time. I can kind of see how that could be useful. So we could use it to quickly figure out how grumpy the owner was during any time window, right?
You got it. Let's say you want to know the total number of grumpy customers between minute 5 and minute 10. With the prefix sum array, all you got to do is subtract the prefix sum at minute 4 from the prefix sum at minute 10, and boom, there is your answer.
Wow, that's super efficient. No need to go through each minute and add up the grumpy customers one by one.
Right.
We just do a quick subtraction with this pre-calculated array. It's like a shortcut to the answer.
Exactly. But there's a trade-off, right? Building and storing this prefix sum array, that takes extra memory.
So it's the classic space-time trade-off.
Right.
If we're worried about memory, maybe the regular sliding window is better. But if speed is what we need and we have the extra memory, then the prefix sum could be a big win. It's like choosing between a fast sports car that uses a lot of gas and a more fuel-efficient car that's a bit slower.
Exactly. The choice depends on what's most important in each situation. Sometimes memory is the bottleneck, and sometimes it's speed.
This is really interesting. I'm seeing how even a problem like this grumpy bookstore owner, one can have so many different solutions, each with their own pros and cons. It's like we've got a toolbox full of different tools, and we've got to pick the right one for the job.
That's a great way to put it. Just like with real tools, knowing how each one works and when to use them is key. There's rarely a one-solution-fits-all in programming.
So this is really giving me a clearer picture of how to think about these optimization problems. But before we go too far, I think it'd be helpful for our listeners to see how this actually translates into code. Could we, walk through some pseudocode for the sliding window and the prefix sum, just to make it a little more concrete?
Sure, let's start with the sliding window where we're using those two separate sums, one for grumpy and one for not grumpy. It would look something like this.
Okay, so the first thing is we got to initialize our variables, right? We need one for each of our sums, grumpy customers and not grumpy customers inside the window. And we need another one to keep track of the biggest window sum we've seen so far.
You got it. We're setting up our workspace. Then we start looping through the customer data, looking at each minute of the day. For every minute, we check was the owner grumpy. If they were, we add the number of customers to our grumpy sum. If not, we add it to the not grumpy sum.
So we're sorting the customers into two groups, depending on the owner's mood. And then as the window slides to the next minute, we adjust those sums.
Yep, exactly. We subtract the count from the left side and add from the right side. And we make sure we're adding to the correct sum based on whether the owner was grumpy or not.
So we're keeping this running total of grumpy and not grumpy customers as the window moves. And of course, inside the loop, we're constantly checking, is the current window sum bigger than the maximum we've seen so far? If it is, we update our maximum sum. It's like we're always searching for that happiest window.
That's it. And then once we've slid the window across the entire day, we add that maximum window sum to the total number of customers who are already happy. The ones where the owner wasn't grumpy naturally. And that's our final answer. The maximum possible number of happy customers.
That makes perfect sense. It's like we're finding the best way to boost happiness by carefully placing that not grumpy time.
Mm.
What about pseudocode for the prefix sum approach? How does that work in code?
For prefix sum, the first thing is to create that array to hold our prefix sums. We start the first element at 0, because before the day starts, no grumpy customers. Right, that's our starting point.
It's like our baseline grumpiness before the bookstore even opens. And then we go through the customer data, minute by minute, calculating the prefix sum at each point, right?
Exactly. So if the owner is grumpy at a certain minute, we add the number of customers to the previous prefix sum. If not, we just use the same prefix sum from the previous minute. It's like building up a history of the grumpiness level.
Like watching a grumpiness meter. It goes up and down as the day goes on. Once we've got that full prefix sum array, we can slide our window across it, just like before.
Right, you got it. For each position of the window, we use those pre-calculated prefix sums to figure out the total number of grumpy customers in that window. Remember, it's just a subtraction.
And of course, just like before, we keep track of the biggest sum we see as we slide along. And that biggest sum, plus the initial count of satisfied customers, gives us the best possible outcome.
Perfect summary. You've really grasped how both the sliding window and the prefix sum techniques work.
This has been such an eye-opening deep dive into this grumpy bookstore owner problem. It's amazing how something that sounds so simple at first can lead to all these cool algorithms and strategies for optimization. And it's really all about figuring out those clever tricks to handle bigger and bigger data sets.
It shows the power of computational thinking. By breaking down the problem into smaller pieces, understanding the trade-offs, and choosing the right tools from our algorithms toolbox, we can create elegant solutions that work really well, even when things get complicated.
Absolutely. But before we wrap things up, I want to leave our listeners with one final thought, a little twist to really make them think. So we've been focused on getting the most satisfied customers we can, like finding the biggest peak of happiness, right? But what if our bookstore owner, what if they had a different goal? Like what if instead of the total satisfaction, they wanted to minimize the variance in customer satisfaction, make it more consistent throughout the day?
Ooh, that's a really interesting twist. So instead of just aiming for that one big burst of happiness, now we're trying to create this, I don't know, this smoother experience for everyone, a more consistent level of satisfaction.
Yeah. So we're not looking for the absolute best spot to put that not grumpy time anymore. It's more about using that time to even out the ups and downs of customer satisfaction, like smoothing out the rough edges of the day. You know what I mean?
It becomes a balancing act, right? We want to try and offset those really grumpy times, but we don't want to create these big swings in satisfaction between the not grumpy period and the rest of the day.
Right. The sliding window and the prefix sum, those are great for finding that one optimal window.
Yeah.
But this new goal, minimizing the variance, that feels different. Would those techniques still work here?
They might not be the best fit for this kind of goal. We might need to look at other algorithms that are designed to minimize variance, tools that are better at smoothing things out and creating that balance.
It's so interesting how just a small change in the goal, like a shift in how we're thinking about the problem, can take us to a completely different set of tools and strategies. It really shows how important it is to understand the problem first, not just jump right into solutions.
I totally agree. It highlights the power of, well, what we call computational thinking, right?
Yeah.
Defining the problem really carefully, thinking about all the details, and then choosing the right approach, the right tool for the job. And sometimes that means coming up with a brand new tool.
Well said. This has been a really great deep dive into this grumpy bookstore owner problem. We started with what seemed like a simple optimization, and we ended up exploring all these different techniques: brute force, sliding windows, prefix sums, each with its own advantages and disadvantages. And we even touched on how tricky it can be to minimize variance. which adds a whole new layer to the problem.
It's been a fun journey. We've seen the power of algorithms and how important it is to pick the right approach. It's a good reminder that there's always more to learn, new ways to solve problems, and always room to get creative when you're coding.
I think our listeners are walking away today with a much better understanding of how to tackle these optimization problems, whether it's a grumpy bookstore owner or any other situation that needs some strategic thinking and some clever algorithms.
And hopefully, they've also gotten a sense of just how elegant and, well, beautiful a well-designed algorithm can be. The kind that solves tough problems efficiently and gracefully.
I agree. Thanks for joining us on this deep dive, everyone. Keep those coding skills sharp. And remember, there is always a new challenge waiting for you.